demonstration on acceleration. I have a cart that I used for the same demonstration, but instead of having the accelerometer on there, I've got what's called a vertical cannon. So the vertical cannon has, when you turn it on, it's got this cannon here that if you press it down, that little spring-loaded plunger, it stays down because there's an electromagnet holding the spring compressed. Now if you put something in between these two photo gates,
Sorry.
okay, this is being filmed, this is a tape. If you put something in between these two photo gates, it defeats the electromagnet. So if I put this piece of paper in between there, listen. Okay. So this piece of, there's a little piece of metal here that's at just the right height, so that if I set it, put the ball in there, when it goes by, grab that, it should have landed right back in the can. You get the idea though. So I'm going to build a little bridge. And we may have to do this a few times because it doesn't always work exactly the way I like it to. So the question is, if I set the ball down in the vertical cannon and I let it go, when it gets to this point and the ball comes out, what happens after that? What will happen? Ideally. Okay, Lindsay did a little, but what does that mean?
It'll go over the bridge and land back into the plane.
Okay, so Charlotte, the taller, says it'll go over the bridge and land back in the cannon. Okay, why?
Projectile motion.
Oh, come on, say more.
It's still going to be moving forward at the same speed as the cannon.
Okay.
And it'll be free falling back on down.
Okay. All right, so let me paraphrase. Let's say that the cannon is moving at a meter per second. That means the ball is moving at a meter per second. When it's projected, it's still moving at a meter per second because that free fall motion won't affect the horizontal motion. So it should free fall up and down, all the while continuing to move forward with the cannon. Don't you see that this is just like that last video? It's really the same. That bowling ball was moving the same speed as the car. When it was projected up in the air, it continued to move that same speed as the car. It just had these two motions that were happening at the same time. I'm going to be so happy if this works in the first try. It hasn't worked on the first try yet today. Oh. You were supposed to catch that.
You didn't say that.
Okay. That
Don't
was
do
great.
it again. Don't do it again.
I almost hate to do it again because
Don't do it again.
Don't do it again? Okay, can you catch it this time?
Yeah.
Okay. Come on, Kara.
I was taking notes, Mr. Ladd.
All right, actually, that worked perfectly both times. It's the first time today. I did it first period. Maddie, how many times do I have to do it? One more time. Here, get ready.
Oh.
Right, it landed in there.
in there.
All right, thank you. Okay, so what's important about that? Well, again, it shows the independence of the vertical and the horizontal motion. The ball already had the forward motion of the cart. It kept that forward motion of the cart because its free fall motion didn't change that, didn't affect it in any way. So it just, as it was free falling up and down, it just tracked right along with the cart. And of course, when it came down, it had to be in the same position as the cart. Okay, cut.
Wait.